Hello team, in this lesson we are going to talk about what Iterable and Iterator interfaces are. We would investigate source code of these two interfaces and also will answer what is the role of these two interfaces in Java Collections framework. After this lesson you will never confuse these two interfaces. We are going to learn three types of Iterator. And at the end of the lesson I also want to demo you what ListIterator is and how it is different from Iterator. Let's start. I believe you remember that first time when we looked at collection interface, we found that collection interface is extended from iterable interface. Do you remember that? As you can see on this class diagram, iterable interface has only one method, iterator. This method should return object of iterator type. That means that each implementation of collection interface in Java should have iterator. I believe that is all what we can say about iterable interface. This interface is to tell that I'm the type that has iterator. More interesting to talk about what an iterator is. And to answer this question, I suggest reviewing source code of iterator type in Eclipse. In few words, iterator is a type that can go over each element in container. That's it. You might be wondering, is it really so hard and separate type is needed? It is not so hard. But imagine two simple cases. You have array list and linked list. In array list we have to get elements from the array by their indices. In the linked list we have to get the reference of the next node from each node to iterate over elements. Can you see that the way how to iterate over each element, even in these two collections, is completely different? That's exactly the reason why we need to come up with some abstract type like iterator to set the interface that should be implemented by specific implementations of collection interface. So, let's sum up what iterator is. Iterator is an interface that allows access to the elements in container and navigation in collection, including iteration, or in other words looping, over each element in any collection without knowing the details of implementation of specific collection. Now we are going to learn the interface of iterator type. It has two abstract and two default methods. Let me explain what each of these methods is about. HasNext method returns true or false. It tells us whether the next element is present. We'll use this method in loops to check if it's worth to go on with our loop, or we reached the end of the collection and we have to break the loop. Next method returns the next element in collection. Be careful, this method may throw no such element exception and interrupt your program execution in case you called next method, but there are no any elements there. That is the contract of the iterator interface. We can do nothing about that. That's why before calling next method we have to always call HasNext method. Remove method, supposed to remove the last element returned by next method. And now attention, this method can be called only once after each next method call. We can't call 2 times next method and after that call 2 times remove method. That is the way how iterator should work. In case you would call remove method without calling next method, or will call remove 2 times in a row in your program will be stopped with illegal state exception. But there is more interesting thing here. By default, remove method throws unsupported operation exception. That means that in case we would call this method, our program will be stopped with the exceptional situation. Now I'm going to say not only my opinion, but opinion of different engineers too. It is senseless to declare a method in the interface that is not needed. Yes, exactly. This exception here, unsupported operation exception, tells us that by default this method is not supported. Don't do that during implementation of your interfaces. Why? Let me explain. Here we can see violation of one of the solid principles. Can you guess what solid principle is violated in the iterator interface? Exactly. I principle, interface segregation principle. According to this principle, no client should be forced to depend on methods it doesn't use. Originally, according to the documentation, iterator type was created to iterate over elements, but not to remove them. How would I recommend implementing this? I would create something like removable iterator that extends iterator type and would let client of my code to decide whether they need remove method or no. because right now each implementation of Iterator interface has a remove method even if it is not overridden there. This is default method and there is no need to override it. But this doesn't make life of engineers easier, because we still can call remove by mistake and rely on the fact that this behavior should be supported in Iterator. Now you know that there is an exception here. The other side of this violation is that in case in Java Collections Framework engineers would follow all OOP principles, including interface segregation principle, there would be big bank of interfaces that is hard to learn and hard to remember, and even harder to maintain. So, as you can see, programming, like everything else in our lives, is all about trade-offs and compromises. The last but not the least method here in Iterator interface is for each remaining. This method takes functions that should be applied for each element that remains in the container. The usage of this method requires knowledge of functional programming in Java and knowing interfaces from the Java util function package. That's why today we will not demo work of this method, but we will demo it in the lesson about functional programming. Okay, now when we know Iterator interface, I suggest learning how it works and to practice a bit. And I'd like to visualize the way how method next and remove works. Let's take a look at this slide. I want you to imagine that Iterator works like a cursor. Namely, at the beginning it stands right before the first element. When we call next method, it returns the next element to us. And now cursor stands between the first and the second element. In case we call next method one more time, cursor is moved to the position between second and the third element, like you see on the slide. Now, when we call remove method, Iterator works as a backspace key on the Windows machines. It removes elements that stands right before the cursor. Does it make sense? Now let's get back to Eclipse. For the sake of the demo, I created this demo file to practice a bit with Iterator. Let me run this program and walk you through the different cases that are listed here. At the beginning, I created a list of integers to play with. You already know this construction, so there is nothing special for you here. Now let's iterate over each element in container. I call Iterator method on our list that returns Iterator object parameterized by integer type. This means that when I will call next method, Iterator will return object of type integer, like it's specified here in diamond operator, but not the object of type object. After that, we have while loop, and I check in condition statement here whether Iterator has next element or no. And if yes, I want to print it to console. Next method returns me the reference to the next element in my container. Is everything clear here? Hope it is. The next example is more like a practical tip. Some of my students that I taught offline feel concerned that they can't reuse the same iterator once we iterated over all elements. So, after the previous loop, our iterator cursor is at the end of the container, and has next method will return false. That is exactly the reason why we see this console output here. But what to do now? We can use the same variable and initialize it with a new iterator object, because there are no methods to reset cursor of the iterator back again to the beginning, like we did here. So that is fine. Now I want to demo how remove method works. Let's remove all even numbers from our container. We call next method to get element from the container. After that we check whether this number is even, and if yes, then we remove it. You can see that I don't violate the rules of remove method usage. I call remove method only after I called next method. And also, there are no multiple invocations of remove method. You also can notice that Iterator that is implemented in ArrayList overrides remove method and doesn't throw unsupported operation exception like default implementation of remove method does. Now, if you are not familiar with the exception topic yet, let me show you an example what exception means and how Iterator may throw exceptions. Let me uncomment these lines of code. I initialized again my iterator variable with the new iterator object. After that, I call remove method without calling next method. Let me run my program now. And here we can see a legal state exception. The same exception will be thrown in case we would call remove method 2 times in a row. That is something what you have to remember. At the end of the lesson, I will share with you home task where you will have opportunity to practice your skills in writing your custom iterators. Let me comment these lines to be able to execute code that is written after this one. Let me also show one more important exception that might be thrown by Iterator. That is concurrent modification exception. I will uncomment these lines of code and will demo it to you. Imagine that we created Iterator, and when we started iteration, we removed element from the container, but not with the help of Iterator, but just by using remove method of our list. This is just an example. In real life, it might happen that you created an iterator on the list that is shared between different threads of execution, and somebody in other thread did some modifications to your list. And after we would call next method, we would see concurrent modification exception. That means somebody modified the collection after iterator had been created. Iterator object noticed that and want to let us know that collection that we are iterating over is not up to date, and that information about elements that I will read with the help of this iterator is not relevant anymore. This type of iterator is called fail-fast iterator. That is default implementation of iterators in majority of collection implementations that are not developed to be used in multi-threading environment. What to do in this case? In case you have iterator, make sure there is no other place in your code where you modify the same collection simultaneously. If you do modify collections from different threads of execution, then you need fail-safe iterator. That is the second type of iterator that usually called fail-safe. Let me comment the concurrent modification demo code to be able to proceed with the next one, and I run the program again. Usually thread-safe implementation of collections also implements fail-safe iterator. To explain you in short how it works without going deep into the details, fail-safe iterator makes copy of the internal data structure and iterates over the copied data structure. Any structural modification done to the iterator doesn't affect the copied data structure. So, original data structure is changed. This type of iterator creates a snapshot and iterates over elements in this snapshot. The drawback of such iterator type is obvious. In some cases, you may not receive latest and up-to-date version of elements in case collection is modified from the different threads. But sometimes it might be not critical for you. Here we have thread-safe list implementation, copy and write array list. I initialize it with the elements that are in our integers list. I create iterator. Interface of the iterator is the same everywhere. That's why I use the same variables that I had created. As I already mentioned, fail-safe iterators create the snapshot of the container. To prove you this, here I add another integer to this container. And now when I iterate over elements, and as in previous example I remove elements from collection without iterator, I still print elements from the container to the console. But when I print the collection to console, it has only one number that we added after iterator creation. This proves that iterator creates snapshot with elements, and this snapshot is not updated as we update collection after creation of iterator. There is also a third type of iterator that is called weakly consistent. It is called so because this type of iterator can reflect some, but not necessarily all of the changes that have been made to the collection since iterator is created. Let me show you this. I declare a new variable of collection type parameterized with the integer type, and I create object of concurrent linked deck. This collection implementation has weakly consistent iterator implementation. I create an iterator, and now attention. Similarly to the previous example, I add new integer here. And now, when I'm iterating over each element, I can see that new integer already was taken into account here. But as it is said in the documentation, there is no guarantee that all updates to the collection will be taken into account by the moment iterator would reach the specific element. Can you understand now what is weakly consistent iterator? So now we may say that we learned three types of the iterator. The last thing that I would like to learn with you today is a ListIterator. Let's look at this interface. The first thing that you can see is that ListIterator extends iterator interface. The main feature that is introduced in ListIterator is to iterate over elements in reverse direction. If iterator can go over elements from the beginning to the end, the ListIterator can go from the end to the beginning. It also declares methods that are absent in iterator interface. They are hasPrevious. It is similar to hasNext method but checks if there are any element in another direction. Previous returns the reference to the previous element in the container. NextIndex to get the index of the next element. PreviousIndex. It returns the element that would be returned by previous method. Set replaces the last element that was returned, and this is important to understand. It replaces element that was returned after calling next or previous method. In case set method is called without calling next or previous method before that, illegal state exception is thrown. Add method adds element to the container. So you can see a few more important features of the ListIterator. It also allows us to add element to the container during the iteration over elements or to substitute element. Let's look at the ListIterator demo now. I created separate file for that. Let me also execute this program. I have the same container with integers as in previous example. The list interface declares ListIterator method, as you remember. This method returns us the object of ListIterator type. One more interesting feature. We can get ListIterator from the specific position if we need. I can't imagine the case when I would use it, but it is an interesting feature to know about ListIterator. For example, here I set ListIterator as the second index. Here is the position of the cursor in the index 0, here position of the cursor in the index 1, and here is 2. So, the next call of the previous method should return number 2. And now you can see in the console output that 2 is returned. Now I want to update this element. I call set method and pass 20 to this method. So the element that was returned previously is substituted with 20. So my next call of the next method should return 20. And here in console you can see that ListIterator works exactly in the way we expect it to work. In case I want to add element with the help of ListIterator, I call add method. And the item is inserted right before the cursor. So in case I added 21, I can get it now by calling previous method. And here's 21. And remove method will return the last item that was returned either by next or previous method. In this case, after invocation of remove method, 21 will be removed. And here we printed all elements to console to prove this. Now, I believe you have full understanding of how Iterator and ListIterator works. Let's recap what we have learned today. Today we learned what Iterable is. We also understand what Iterator is. Now we know the difference between these two interfaces. On real examples we saw how Iterator works. In this lesson we saw what exceptions might be thrown by Iterator, including concurrent modification exception, illegal state exception, unsupported element exception, and no such element exception. We learned 3 types of Iterator: fail fast, fail safe, and weakly consistent. And at the end of the lesson we learned ListIterator and how it works. Now let's review your homework. In short, you have 2 coding exercises here. You have to implement Iterator and ListIterator for the default myList class that you implemented in scope of your homework about lists. Read attentively all requirements here. I prepared for you method signatures and description of interfaces. All you have to do is implement methods. You will see here some requirements related to exceptions. In case you're not familiar with exceptions topic, there is absolutely no harm, because I wrote the line of code that you have to write when exception should be thrown. That's it. Don't skip this homework, it is important for understanding of the topic. Thanks a lot for your attention. See you in the next lesson.